Good morning, students. In continuation with chapter Surface Chemistry, today we shall be studying about shape selective catalysis by zeolite. Shape selective catalysis, what does it means? It means the catalytic reaction which depends upon the pore structure of catalyst and the size of reactant and the product molecule is known as shape selective catalysis. Zeolites are shape selective catalysts because of their honeycomb like structure. They are microporous. Actually, the zeolites are aluminosilicates with three-dimensional network of silicates in which some silicon atoms are replaced by aluminium atoms, giving ALOSI framework. These zeolites are very important. They are used in petrochemical industry for converting alcohol directly into gasoline by dehydrating it to give the mixture of hydrocarbons. Zeolites are mainly used in petrochemical industries for the cracking of hydrocarbons and isomerisms. Enzymes. Enzymes are known as biocatalysts. They are nitrogenous organic compounds. They are known as a biocatalyst because they catalyzed various biochemical reactions. These enzymes are specific in nature. For example, cane sugar on hydrolysis in the presence of enzyme invertase can be converted into glucose and fructose. In the same way, glucose can be converted into ethyl alcohol in the presence of a special type of enzyme which is known as ENZYMES. Now, how do these catalysts work? Actually, on the enzymes, there are number of cavities which are present on the surface of the colloidal particles of enzyme. These cavities are of characteristic shape and possesses active groups such as NH2, COOH, and OH. And these are actually the active centers on the surface of the enzyme particle. The molecules of the reactant substrate, which have the complementary shape, fit into these cavities, just like a specific key fit into the lock. On account of the presence of active groups, an activated complex is formed, which then decomposes to give the product. Now, what are the characteristics of enzymes, or what are the characteristics of enzyme catalysis? First is high efficiency. It means that one molecule of enzyme can transform 1 million molecules of the reactant per minute. Highly specific in nature. They work on the optimum temperature. They work at the optimum temperature. The enzyme catalyst give higher yield at the optimum temperature, that is at 298 to 310 Kelvin, which is a human body temperature. They work within the pH range of 5 to 7. Activators and the coenzyme can increase the efficiency of the enzyme catalysis. Activators are generally metal ions such as sodium, manganese, cobalt, and copper ions. These ions, when weakly bonded to the enzyme molecule, can increase the catalytic activity. Now, what is coenzyme? Coenzymes are the non-protein vitamins which, when present along with the enzyme, can enhance the enzyme activity. Effect of inhibitors and poisons. Inhibitors and poisons can slow down the rate of enzymatic action and the use of many drugs is based on the enzyme inhibition action to those drugs. Colloid. Colloid is a heterogeneous system in which one substance is dispersed as a very fine particle in the another substance, which is known as a dispersion medium. So depending upon the size of the solute particle, the solution can be categorized as true solution, suspension, and colloid. In true solution, the size of the solute particle is less than 10 raised to the power of minus 9 meters. Whereas in suspension, it is more than 10 raised to the power of minus 6 meter. But in colloidal solution, the size of the particle is between 1 to 1000 nanometer and can pass through the filter paper, but cannot pass through the animal or the vegetable membrane. Dispersed phase means the substance which is distributed in the dispersion medium in the form of a colloidal particle, whereas dispersion medium is the medium in which the substance is dispersed. So on the basis of there are the certain criteria to classify the colloidal solutions. Colloids can be categorized on the basis of the physical state of dispersed phase and the dispersion medium, on the basis of nature of interaction between the dispersed phase and the dispersion medium, and the type of particles of the dispersed phase. Depending upon whether the dispersed phase or the dispersion medium are solid, liquid, or gases, there are 8 types of colloidal system. I would like to tell you a gas mixed with another gas forms a homogeneous mixture. Hence, it is not a colloidal system. Now, the example of various colloidal systems are solid to solid, known as solid sol. Example is colored glasses and the gemstones. Solid to liquid sol. Sol means solid in liquid. Solid dispersed in the liquid dispersion medium. Example is paint and the cell fluids. Solid in gas are aerosols like smoke and dust. Liquid in solid is gel. That is cheese, butter, and the jellies. Liquid in liquid form the emulsion. Example is milk and hair cream. Liquid in gas are aerosol like fog, mist, cloud. Gas in solid is a solid sol. Pumic stone, foam, rubber. Gas in liquid is a foam like froth and whipped cream and soap leather. Now, depending on the nature of interaction between the dispersed phase and the dispersion medium, the colloidal sols can be categorized into 2 categories. One is lyophilic and second is lyophobic. Lyophilic means solvent attracting. Lyophobic means solvent repelling. So, lyophilic colloidal solutions or lyophilic colloids are the colloidal sols which are directly formed by mixing substances like gum, gelatin, starch, rubber, etc. with the suitable liquid which is known as a dispersion medium. One very important characteristic of the lyophilic sol is that they are reversible sol. What is the meaning of reversible sol? It means if the dispersion medium is separated from the dispersed phase, say evaporation, the sol can be reconstituted by simply remixing the dispersion medium. Now, they are quite stable and cannot be easily coagulated. Whereas lyophobic sol, as the name indicating that it is liquid hating, the substances like metals and their sulfides, when simply mixed with the dispersion medium, do not form the colloidal sol. Their sols can be prepared by the special methods. And these sols are irreversible, means that they cannot be reconstituted by simply mixing the dispersion medium when the dispersed phase and the dispersion medium is separated. And these sols can be precipitated. They once precipitated cannot give the colloidal sol. And these sols can be precipitated or coagulated on adding the small amount of electrolytes. Lyophobic sols need stabilizing agent for their preparation. Now we'll see that what is the difference between the lyophilic and the lyophobic sol. Lyophilic sols can be easily prepared by directly mixing with the liquid, that is a dispersion medium. Lyophobic, they cannot be directly prepared, but they are prepared by the special methods. Lyophilic are quite stable and cannot be easily precipitated. Lyophobic can be easily precipitated by adding small amount of electrolyte. Lyophilic are reversible in nature. Once precipitated, can reform the colloidal sol by simply remixing the dispersion medium. Whereas lyophobic are irreversible in nature, once precipitated, cannot form the colloidal sol by simple addition of the dispersion medium. Their surface tension is lower, that is in case of lyophilic, than the dispersion medium, whereas in the lyophobic sol, their surface tension is nearly same as the dispersion medium. Now, classification on the basis of the type of the particles of dispersed phase and the dispersed phase, they can be classified as multimolecular, macromolecular, and associated colloid. First of all, we'll be discussing about the multimolecular colloid. Multimolecular colloids are formed when, on dissolution, a large number of atoms or small molecules of a substance aggregate together to form a species having the size within the colloidal range. Example is like gold sol and a sulfur sol are the example of multimolecular colloid. Next is macromolecular colloid. Macromolecules are the molecules which have the large size and have the higher molecular masses. In suitable solvent, these macromolecules, they form the solution in which the size of the macromolecules comes within the colloidal range. Example are like starch, cellulose, protein, enzyme. There, they can form the macromolecular colloidal sol. Even man-made macromolecules are like polythene, nylon, polystyrene, synthetic rubber. Their sols in a suitable solvent are known as the macromolecular colloid. Next is associated colloid. Substances behave as electrolyte at lower concentration, but however, if the concentration is higher, they show the colloidal behavior due to the formation of aggregates called micelles. Such substances are called the associated colloid. For example, soap and detergent. Micelle formation occur at a particular concentration known as that is known as the critical micelle concentration. The critical micelle concentration means the concentration above a particular concentration. When associated colloid is formed, that is known as the critical micelle concentration. And critical temperature is the temperature above which the colloidal sol is formed, which is also known as a Kraft temperature. There are some characteristic properties shown by the colloidal solution. One of the characteristic property of the colloidal solution is the Brownian movement. What is Brownian movement? Brownian movement means the zigzag movement of the colloidal particle. When colloidal sols are observed under microscope, the scattered light were seen moving in a zigzag motion. This zigzag motion of the colloidal particle is due to the unbalanced bombardment of particles by the molecules of the dispersion medium. The Brownian movement has a stirring effect which does not allow the particles to settle and thus responsible for the stability of the soul. Another very unique property which is shown by the colloidal solution or the colloidal soul is the Tyndall effect. What is Tyndall effect? When a beam of light is passed through the colloidal solution, its path is illuminated. This phenomena is known as the Tyndall effect. This Tyndall effect is due to the scattering of light by the colloidal particles in all directions in space. The scattering of light illuminates the path of the beam in the colloidal solution. Tyndall effect is observed only when following conditions are satisfied. First, the diameter of the dispersed particle is not much smaller than the wavelength of the light used. Second, the refractive indices of the dispersed phase and the dispersion medium differ greatly in magnitude. Thank you.